Dear colleagues, today I want to show you the interrelation between the well and the pump. It's important to understand because pumping water from a well is not the same like pumping water from a tank. In our tank we have always a constant water table, but in a well the more we pump, the more drawdown we have in the well. Okay, here I want to show first the experiment. This white pipe represents the well field. Here, this one, we see it from top later. This is the well, which sucks water out from the well field. And here we have the two water levels. This is the phreatic level of the well field, or the static level of an unconfined well field. This experiment, what I show you, is now only for an unconfined aquifer. Yeah? So this is an unconfined well field, and this is the aquifer, unconfined aquifer. An aquifer which is free, which is not under pressure in the underground. So this one is the static level or the phreatic level, and this one is the dynamic level of the well, the dynamic level inside this pump. We see here this is the well, this is the suction pipe, down there is the pump, let's say a submersible pump, but in our case I have a normal pump, household pump. I have a water meter to check the flow, and the water we are getting out is going down again in the well. Here the water returns into the well. Yeah, these are only plugs, nothing to do. And here we have the two pipes for the metering the aquifer and the dynamic level. In this case, as we are pumping very slowly, let's say with a small pump, the dynamic level is going a little bit down. Yeah? Let's say this is the aquifer or the phreatic level of the groundwater or the groundwater table, and this one is the dynamic level. So according to pumping, this dynamic level will go down. Now we will see on the experiment, we will increase pumping, and so we will see how the dynamic level goes down. Nearly no pumping, dynamic level and phreatic level nearly the same. I increasing the flow, pumping flow. The dynamic level goes down, the flow of the pump increases. We increase more the flow, we see the dynamic level drops, flow increases. Now we have quite a strong flow. This is why every well has to have a special pump or exactly calculated pump. Our next experiment is we want to compare directly the output of the well at the same depth but with a different phreatic level. The first one, we start with 60 meters, then 80 meters, then 100 meters, 120, 140. The second is we lower the phreatic level and start in 60 meters, then 80, then 100 and 120. So we can compare directly the yield of the well if there is a different phreatic level. We start first with 60 meters lowering. Go up again to the 0. Now we have a drawdown of 60, static level 0. 13 seconds, 5 liters. Now we have a drawdown of 80. Let's see the flow. 12 seconds. Now we have a drawdown of 100. The flow is 9 seconds. Now we have a drawdown of 120 and the flow is 8 seconds. The next is we descend the phreatic level to 50. Now we go down with the dynamic level to 60. Here we have 50, that is okay. And here we have 60. Let's see how much water this pump can bring out now. You see it's a very little flow and it will take quite a long time. 37 seconds. Next is we go down with the dynamic level to 80. 80 and 50. Let's see the flow. 22 seconds, 5 liters. Now we drop the dynamic level to 100 and meter the flow. 17.5 seconds, 5 liters. We still go down with the dynamic level to 120. Now we lower the dynamic level to 120. Let's see the flow. 15 seconds, 5 liters. And finally, let's go down to 140. Phreatic level still 50, but dynamic level 140. Let's see the flow now. 12. What is that? Now let's make the interpretation of our test. In the first test, when the phreatic level was high and with a drawdown of 60 centimeters, we could get a flow of 0.38 liters per second. When the phreatic level was low, with a drawdown of 60 centimeters, we got a flow of 0.14 liters per second. That is less than a half. When the phreatic level was high and we had a drawdown of 80 centimeters, the flow was 0.41 liters per second. And when the phreatic level was low, 50 centimeters less, we had a drawdown by 80 centimeters and a flow of 0.22 liters. That means about half of the flow with a normal well. What I want to say is, if we use a pump, if we use the same pump, when the groundwater dropped down, the same pump we had before the groundwater level dropped down, then we have a extremely strong flow or extremely strong exploitation of the well. That means we can get sand, we have an extremely high pumping head because the groundwater, the drawdown goes very low down. So we have a high pumping head. That means that our pump will be not efficient anymore, or it runs out of its optimal operating point. So we have an inefficient pump. We have the risk of sand in the well, and it can also happen that the pump runs dry. So in this case, when the groundwater level drops, we have to check if another pump is necessary. Normally it is. So we have to use a smaller pump with more head and less flow. We have to make a test on our well, like we did now. We can do it also in our big well. We can make a test, and with this test, after this test, we have to determine which pump has to be installed. Now we desample the system and see how it works. This is the filter. This is the plug. Here, this is the well. The inner hole of the well is the metering pipe of the dynamic level. This little filter is the metering pipe that goes to the metering pipe or to the hose of the phreatic level. And this one is the return from the pump. The water which goes back from the pump, from the water meter, returns into this area again and enters through the filter into the casing pipe of the well.